And I told you, as far as your test goes, whatever we get to Friday, don't try to stall me or anything, but whatever we don't get through Friday, then it won't be on your test. Or if it was on your test, then it'll be extra credit or something. Okay? Isn't this clever? Like, look at the moon. I just think it's amazing. What do they call it when you have a full moon and it's at perigee? Supermoon, yeah. What do they call it when you have a full moon and it's apogee? Adorable. So one of the things about the moon is it's a misnomer. We talked about this on Friday. Misnomer to say that there is a dark side to the moon. Okay, that doesn't work. But it is true to say that there's a far side to the moon. I have a few slides to kind of reinforce that. So of course that's the sun. Yep. And we have the moon. I'll grab this one that says, you guys told me near side and far side. So what that means is the near side to the earth. So the thing is like this slide says, if the moon did not rotate. Now, how long does it take the moon to orbit the earth once? Do you remember? What? 29 and a half days, about 4 weeks. It'd be 28 days, it'd be 4 weeks, but about 4 weeks, yeah. So we got 1 week here, 1 week here, 1 week here, and then 1 week here, yep. So if it didn't spin, then this is what it would look like. Where we would see, if the moon didn't spin on its axis of rotation, we would see this side here, and then we would see this side. We would see both sides, okay? And this is showing it, spinning on its axis as it orbits the Earth. Starts with the letter S. What do we call that special relationship between its rotation and its orbit? Synchronous rotation. Very good, synchronous rotation. And a lot of moons do that. Jupiter's 4 Galilean moons are all in synchronous rotation with Jupiter. So, cool. So this is a figure to kind of just reinforce synchronous rotation. So down here you see this gal right here is pretending to be the moon. And here you see her not spinning. So if the Earth is right here, this little orb, sometimes you see her back and sometimes you see her front. But here she is spinning. She completes 1 spin, the same amount of time it takes her to complete 1 orbit. 1 spin on its axis to complete 1 orbit about the Earth. So synchronous rotation. Yep, yep. So what I'm hoping is that we're all good with, and it might end up to be on the unit exam, this whole idea of a, near side and far side. Do you guys remember, what does that, we're going to see it, I think, coming up. What's the difference between the appearance of the 2 sides? Which one's prettier? The near side's prettier, yeah. Yep. And actually, I had a student get this poster for me one time. And so this over here is the near side, this over here is the far side. That kind of grayish area, we're going to talk, those are called mare. They're kind of like seas, flat areas. And then this over here is like really popped up. So, yeah, here we go. So I'm going to dim the light so we can kind of see these side by side. So here's the near side, and this is the far side. I was thinking like the comic, the far side. So near side, far side. There was a movie, a science fiction movie, and Apollo, maybe it was Apollo, I don't know which one, Apollo 18, I don't know, but that astronauts went over here and they found like rock aliens. It was kind of interesting. This, and I went out online because I wasn't really familiar with this. You guys knew that NOAA, that is actually, or the National Weather Service is part of NOAA, which is actually under NASA. So there is a spacecraft that is in one of the cool Lagrange points, like an orbital thing, or planets have a sweet spot. Out here, so this is the Earth, we have a satellite that's actually over here relative to the moon. Do you know what I'm saying? So yeah. So here's our satellite, and it orbits, it has a really broad orbit around the Earth. And this satellite out there is actually looking at, I just looked at it recently, one of the things it's studying actually is the sun, and the charged particles coming from the sun. So this would be what, the far side of the moon. And since they're both lit up, does this make sense? The sun must be over here. Okay, so that's kind of neat. So I have a few of my pictures. I hope not to bore you too much. But the telescope that I brought up there the other night, that's the telescope I've taken some pictures through. Starts with the letter T. What do we call this place right here? The Terminator. Yep. The Terminator. I'll be back. Yes. What kind of moon is this? What do you think? Starts with the letter C. Crescent. Yep. Makes you younger, doesn't it? Yep. So I took this picture too. Looks like it's a little past a quarter, so it starts with letter G. Gibbous. That's our gibbous. Yep. And but along the Terminator is where you're going to find some interesting kind of shadows. I'm going to show you a video here in a minute that kind of goes along the Terminator. Almost full. So here's one of my moon videos. I won't show you is this a short one? I might not show you the whole thing, but I'm going to post the playlist of my videos that I took through my telescope online or on Canvas. If it's a little shaky, it's because, yeah. But so I got a close-up picture. Can you kind of see this little belly button? That's what we call a central peak. And so, of course, I'm right along the Terminator. And then I kind of shimmy it. This is what people do who have too much time on their hands, right? So to move the telescopes, what I'm doing is called slooh, S-L-O-O-H. So I just think that is so cool. You can kind of see I think the shadows are beautiful. Kind of see these ridges here. There's Mare. That would be like the highlands. There's Mare and highlands. And on my list of things to do is to be able to look at, I'm like, oh, I know what that crater is. I know what that crater is. Here you have a crater inside of a crater. It is so cool. Okay. I've got all sorts of those videos. Going back to it. Where'd you go? No? Okay. So what sort of moon would you call this? I'm going with crescent. Yep. So this is the crescent moon. Oh, by the way, this morning, I thought you guys, yes. So yes, did you see it too?
I like 5 in the morning.
Oh, great. So and the moon was beautiful. So there was the moon, and that was Venus right above it. Oh, no. Yes, the moon was a beautiful crescent. So if you missed it, you'll have to go see if you can catch it tomorrow morning. It's beautiful. So I'm going to go dot, 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 dot. Now this actually, to the naked eye, you would not be able to see this. But if you go ahead and, well, actually I say that wrong. No, sometimes you can see it. You can see Earthshine sometimes. I take that back. Or you can play with your camera and get a little extra light from it. So you can definitely see Earthshine. What Earthshine is kind of what it says. The way Earthshine works is part of the Earth. It's got some sunlight hitting on it, and that is going back up to the sunlight from the Earth is going back up to the moon and then coming back to the Earth so you see it. So Earthshine, it's literally light that's hitting the Earth, going up to hit the moon, and then we see it. So we see the back part. Well, it's not the back part, but we see the non-illuminated part. Isn't that cool? So I have another picture of Earthshine. So you can kind of this is not blown up as much, but you can kind of see another crescent. One of the things I didn't mention when I talked about the phases of the moon whatever's happening kind of on the right, sometimes it's tipped, but kind of on the right side of the moon, whatever happening on the right side of the moon is going to continue. So this is to say, if this is the right side of the moon is all dark, that means it must be a waning process, and it's going to get less and less. Okay. If our crescent was over here, then actually it would be waxing because it's the right side's going to go keep doing what it's doing. So think of that. All right. So back to a few slides. Each talk about tides, which is like here in Iowa, not so much, right? In order for tides to work, you need a large body of water. And tides actually, Newton, Sir Isaac, understood that tides were caused by gravity. Like, really? So, you know, the tides, like, they come in, they go out, right? And they do that every 12 hours or so. And so the reason, well, here's what's happening. Gravity. The biggest player in causing tides in our oceans for Earth is actually the moon. Now, the sun is a secondary player, but the moon is the biggest player. So think of the gravity of the moon basically pulling at the Earth. Okay? It's a mutual attraction. So what is susceptible to being pulled actually are large fluids. That could be the Earth's atmosphere, and I've kind of played around with this. But it could also be the fluid of a large ocean, large body of water. So what happens is the oceans are attracted to the moon. Is that weird? They're attracted here where the moon is, actually kind of in arrears, I want to say, about 5 degrees or so behind its closest point. But also then opposite that is a bulge too. So it's a bulge towards the moon and a bulge on the other side. What you're looking at is you're looking down at the Earth's North Pole. So now picture the Earth spinning. What direction does it spin? Counterclockwise. Picture it spinning counterclockwise. Okay. So this part is going to be over here in 12 hours, and then 12 more hours it's going to be here. So that's why you see where you get it every 12 hours. Yes.
So like when there's like a tsunami or like a huge tidal wave, is that also caused by like more gravity pulling?
Nope. A tsunami is a plate tectonic thing.
Oh, okay.
So basically, if you have your large body of water here, it's really deep, and then you have a disturbance, like an earthquake, and that disturbance causes a shock, a perturbation that is carried through. Now, the thing about a tsunami is it's fine if your water is this deep. You know, you just get a blah, blah, right? But what happens is that wave, and it's kind of like you've seen, like if you drop a pebble, the wave goes like this. Mm-hmm. Okay, so that wave, as it gets closer to shore, is like amplified. And so that's why, you know, it starts like here, but then as it gets more shallow water, so tsunamis are. But kind of related to that is tsunamis can be worse if it's at high tide. Does that make sense? And Hurricane Sandy actually was a bad thing all the way around. But when that hurricane went up our east coast in the New England area, it was high tide. And that was bad. Not only was it high tide, but it was, we're going to see that the sun plays a factor. And it was about new moon. Not only was it new moon, high tide, but it was a super moon. So you really had some help there. So yeah. So that's the moon, and I mentioned the sun is a player to a lesser extent.
Plus also Sandy is going counterclockwise too, pushing the wind in towards land with the water. So
it does go counterclockwise. It has that.
Everything was not going well.
The stars aligned in a bad way.
It was not going well.
No, it was not going well. So we've talked about, now does the Earth really have 2 moons? Not that I know. But here we're just kind of showing 2 weeks apart, the new moon and the full moon. Okay. So the thing about the sun is when the moon and the sun are next to each other, lined up, relative to the Earth, then there's an extra influence. We call those spring tides. Okay, so that would happen here if just this is my near side, far side. Okay, that would happen here, okay? And that would also happen, wait, what phase of the moon is this? What thing? Or somebody say full? If I'm the Earth, yeah, full. Okay, what phase of the moon is this? Now I stopped orbiting, I'm the Earth, I stopped going around the sun, which I won't do that, but what phase of the moon is this? Is new moon, perfect, yep. So here at new moon, we have the sun giving an extra full springtide. And here at full moon, we have the sun and the moon working together to make those two bulges, okay? And then we have something called neap tide. I always think of like the Monty Python movie with the little trees, the shrubs. Anyway, so neap tides are diminished tides, and that is when the moon and the sun are at right angles. So what does that look like? I'm going to put the moon and the sun at right angles from the Earth. So what phase is that? You said this was, throwing off. So you said this was full, so what comes after full? Gibbous comes after full, a waning gibbous, and then what do we have before we get new? The third quarter, very good. The last quarter, yep, a quarter. Okay, this is new. Okay. And what is here, then the moon and the sun, actually the moon's doing its thing to create tides. You'll have tides every 12 hours, but they're diminished because at a right angle is the influence of the gravity of the sun. Okay, so this is third quarter. This is new. Okay, see now I'm kind of throwing up. I need to get my hand on. So sunlit. Sorry. Full, right? Last quarter, right? Keep my sunlit towards that. You guys told me this is new, right? Perfect. What comes after new? First quarter, yep. And then we have the waxing gibbous, yep. And then we're back to full. All right. So springtide, neap tide. So here are a couple images from your textbook. This is like high tide, this is low tide. To me, I'm not like a boat person, but that does not look like a good idea for your boats. It's not bad for your boats. You must be a boat person. Okay. So I went out, actually, this is in the Bay of Fundy in Canada. I went out and got a video of Hopewell Rocks Park for the whole tide thing, and it's actually the same Bay of Fundy, so they are noted for their tides. Why does this, how does this look different than my other videos? What did you think about the Terminator? What would you describe that?
It just fades in.
It just fades in, it's fuzzy, it's not that sharp look. This was a full moon, and I have a friend at the observatory says it's kind of like watching paint dry. I was like, why would you watch a lunar eclipse? Okay. But I think I call it the moon looks like the moon's getting eaten. Right? So little by little, that's what it's going to look like. There's my lunar eclipse. So a solar eclipse then happens. Solar eclipse means the sun gets blocked out. So the sun can get blocked out if the moon, well, here we go. Let's take the Earth out of the picture. Here's the sunlit portion. Here's the moon. Does the moon cast a shadow? It does too. Is it a smaller shadow than the Earth? Yeah. But if the Earth passes in front of the moon's shadow, then the sun will be blocked out. Isn't that cool? And it's kind of a proximity thing and size thing. The disk of the sun, we call the solar disk, the disk of the moon are about the same size. from our perspective. So that's kind of fun. So solar eclipses only happen, what phase is this? New moon. Yeah, that's going to be on that there somewhere. So here's my video of, so it was cloudy here, it rained here, it stormed here. We got some of those too. We went to the St. Joe area and should have gone to Columbia.
Wait, so they both occur during the new moon?
The solar eclipse occurs during the new moon and the lunar eclipse during the full moon.
Oh.
Is that what my slides say? Maybe it's not. Oh, come on, dude. I posted a video the other day and somebody says, I don't know what's worse, you for posting this or me. I know, isn't that terrible? Go away. You for posting this or me for taking the time to watch it. I'm like, what does that mean? I don't know. Okay. Well, I'm not finding it. I'll try one more thing. It's in there. See, I've had 21,223 views. All right, so I won't show you the full 30 minutes of it, but this is what was it, 21st of August? This is what we were seeing. Oops, I'll go back to the beginning. So we were hopeful. I'm bad about being hopeful. And I don't know, can you guys see this kind of, there's a sunspot there, it's kind of exciting. So of course the wispy clouds and all that. Now if I go ahead and fast forward, hopefully you can kind of see the bite being taken out. See how big it is there, and see how big the bite is there. Okay, so it's a bigger and bigger, I call it bite being taken out. But of course all we're seeing is, you kind of have to think of it, silent portion. You kind of have to think of it as the Earth passing into the moon's shadow. Earth passing into the moon's shadow. So anyway, so anybody know when our next eclipse is going to be here in the States? 7 years. Yep, 7 years in April. Yep. So who knows? Maybe we'll chase that one. All right.
But it won't be a total eclipse.
It will. Actually, it's more like 6 minutes instead of totality. The maximum here was 2. If you go to, we're looking at Cape Girardeau, Missouri, and it takes a different path. I have a map to kind of show you what it looks like. Okay. Yeah, it'll be total.
Oh, okay.
It will be total. Okay, so this is kind of what we've been talking about, the two types. This is looking at, this is the moon, that blue orb is the moon there, and you can see the shadow it's casting. Whether it's the moon casting a shadow or the Earth casting a shadow, there are two parts to the shadow. There's the umbral part, and the umbral is the darkest part. And then there's the penumbral part, so you can kind of see the umbral part and the penumbral part of the shadow. So what this says is if Earth passes through the umbral part, that's 1 right here. If you're looking towards the sun, the moon is totally going to block out the sun. That's what that's saying, a total eclipse of the heart, right? Sorry. What's that? Yeah.
I was just seeing stuff.
And then this lighter part of the shadow, that's called the penumbral part of the shadow. And this right here is what you will see. That's a partial eclipse. That's a partial eclipse. So you won't see the entire disk go away. This right here is this one right here, over here. This is called an annular eclipse. Oops, darn it, go back. In an annular eclipse, at the greatest point of the eclipse, anyway, right there. At the annular eclipse, the greatest point of the eclipse, you're gonna see a little rim of the sun. And if you kind of remember here when they were talking about the eclipse, they said even at 95, 96% coverage, here it was not safe to look at the sun. It could really ruin your eyes. So, but annular eclipse you couldn't see with the naked eye. But here's the deal. I'm gonna go ahead and sunlit portion, full or new moon, okay, and we're getting ready for an eclipse here. Does this make sense that is as the moon, if the moon were to kind of move farther from the earth, can you see where actually its shadow, the umbral part of its shadow is going to be more in outer space. It's not going to touch the earth. Okay, here's the earth. And actually the moon is moving farther from the earth little by little. We're losing our moon. Okay. My mom the other day said, "Did you know our moon's moving away?" And so she's like, and actually that will create fewer eclipses. Okay, whether it's over here or over here.
What will it do to the waves, though?
Oh, I never thought of that. How much, that's a good question. The proximity. Less tides? As they talk about how life evolved here on Earth, actually this idea of tides stirring up the oceans was a player in life. So, interesting. Okay, so here we have, this must be, what sort of eclipse are we talking about here? Solar eclipse, yep. Solar eclipse, and as the Earth spun, now for those of you watching on TV, for the solar eclipse, who got the solar eclipse first? Was it West or East Coast? West Coast. And I was talking to my astronomy friends, I'm like, how did that work? Because the Earth spins, the sun appears to rise in the east and set in the west. How come they got it first? And I think his answer was because it's the motion of the moon moving, not the spinning of the Earth. Anyway, that hurt my brain. A lot of things hurt my brain. But, yeah. So as the Earth spins, or as the moon moves a little bit, then that shadow, that sweet spot will change. This is not an annular eclipse. This is actually showing you kind of the atmosphere of the sun. This would be at totality the chromosphere. So I saw some pictures the other day that our eclipse happened. That's so cool. So this over here, what kind of eclipse is this? A lunar eclipse, yep. So this is the moon passing into the Earth's shadow. Yep, yep, yep. And there are a few types of lunar eclipses. They're kind of listed down here, okay? These are all lunar eclipses. There's a penumbral lunar eclipse. It is so boring. It's terrible. It's really subtle. It's really hard to see. It's going through the wimpy part of the Earth's shadow. And then there's a total lunar eclipse, which is awesome. And then there's a partial lunar eclipse. Both of these are cool, I think. So the total lunar eclipse, and I've seen a few of them, and what happens at totality is that the last bite taken out of the moon, and then it kind of, it does kind of change its color. This says red. It just changes its color. Anybody in here seen a lunar eclipse? So did you kind of notice the color change? Yeah. Yeah. So this is why they don't happen every new and full moon. You guys told me this is the plane of the ecliptic, right? And if the full moon happens when it's on the plane of the ecliptic, or if the new moon happens when it's the plane of the ecliptic, bada boom, you have an eclipse, okay? But usually it's tilted out just a little bit. So do you see what angle that is? 5 degrees, yep. So this was the path of totality in the 2017 eclipse. And this is kind of showing you, just for our hemisphere, or just not even just for us, North America. This was August 2017. And what I was talking about is right here, and I think somebody else mentioned it too, is the April, let's say, 8th, okay. April 8th. I'm kind of thinking about camping. I'm like, okay, we can do this. Get a place to camp. Because I don't know if you caught it, all the hype about this last eclipse, but hotels sold out and campsites were selling for like $100. Like, oh. So, yep. So this is, and the fact that it's a little bit wider, that's like the whole, that's why you got 6 minutes instead of 2 minutes. So, it's a thought. There are people that chase eclipses, probably heard about that. So, it would be cool. It'd be expensive. I had some friends who went to, I think it was Hawaii, and one got sick, and so these are, I snagged this as a screenshot. These are upcoming lunar eclipses. And I'll be darned, I mean, they're getting fewer and fewer. But actually, this is West North America, so I don't think that's us. This one says Americas. So, there you go. So we're to a homework slide. Yep. So these will be due when we meet again. And we're going to kind of go into the next part a little bit. So how many of these you need to do? Is it 3 or 4? Let me know. 4 of those. Okay. Pick your favorite 4. Yay! All right. So there's Buzz on the moon with the flag. We already talked about, so what happens when they dropped a hammer and a feather? What happened to them as far as falling? They land at the same time. Yep. And this says that these footprints actually are going to stay there like forever-ish because there's no wind to disturb them.
Forever.
Yep, forever-ish. This is kind of showing you from 1 to, it's like a little storybook, 3, 4, 5. This is showing you the formation of the moon. The best known what the pieces kind of say happened. So early on in the, and we'll talk more about this on Wednesday hopefully, when our solar system was just kind of first started out, there was a lot of extra crumbly stuff, extra random things that was not associated with the planet. Okay, and so there was a lot of bombardment going on. So an impactor probably about the size of Mars actually smacked up against the Earth. And at the time it smacked up against the Earth, we think, and I think I already mentioned this before, I'm looking for my yardstick. It did this to our axis of rotation. What's that? Tilted it, yeah. Like I'm playing charades up here. Yes, it tilted it. Okay. And the other thing that really kind of says this is probably what happened is that this material up here, not the impactor, but the actually literally the stuff from the Earth splashed out, bless you, and then came to rest as an object, and it was rounded and everything due to gravity, become our moon. If you compare the stuff on the Earth, rocks, they actually compare favorably to the rocks on the moon, date-wise and everything, date-wise and composition. So here we have the stuff splashed out. It kind of comes together. It eventually forms a cute little thing we call the moon. So, and we talked about, starts with the letter S, what's the special relationship that the moon has with regard to its rotation and orbit? Synchronous, yeah. So kind of over time, that it got into a nice steady rhythm, synchronous rotation. Here is a look at the moon, close-up look at the moon. So one of the things I want you guys to know, and I think I mentioned this in the Moon Lab, starts with the letter M. What do we call the dark regions? Mare. Yeah, it starts with the letter H. What do we call the light colored regions? Highlights, yep. And I think I handed out something like this the other day at the Moon Lab. A lot of you guys came to that Moon Lab, which was great. But this is just kind of a look for like faces in the moon. I'm liking this one up here. The mare are kind of what make, the eyes and the nose. This is a rabbit in the moon. I'll buy that. Right? Some people see the lady in the moon. I've heard beetle in the moon. I'll just kind of give you some ideas. This one. Some people have a really good imagination. I'm not sure I could see that. So that's what they mean when they say a man in the moon. On the videos, or on the pictures and the videos you've seen from me, and you already have a sense for if you've used binoculars, we saw them through the telescope the other day. We have these cratered regions. It's definitely cratered. When there is a crater, one of the things I want you to know terminology-wise is this thing right here is called the central peak. And then, I don't know if you can see it very good, but there's this kind of landscaping. It's terraced. It's like if you wanted to be able to get from the bottom of the crater up to the outside, you'd kind of have stair steps. And not that anybody created these stair steps, it's just kind of a natural outcome of the way the impact happened. So it's kind of terraced on the edges. Ejecta blanket, I want you to know that term too. This guy right here, oh my goodness, she's just beautiful. That impact crater right there is called Tycho. And it's relatively new. You can tell that by the light color of the ejecta blanket. So the ejecta blanket is that splashy part. Okay, that's the ejecta blanket. This right here is Tycho's ejecta blanket. So just picture an impactor hitting the moon, and it impacts, it creates and there's an ejection of material outward. It leaves behind the central peak. We have some terracing, and we have that stuff kind of fly out. Another term I want you to know is called regolith. Regolith is that powdery stuff that covers the moon up to some very striking depths. Regolith. When I think of regolith, I think of, and we don't use it anymore, but like if you use charcoal in your grill, after you're done with your grill, you have this great powdery stuff, and that reminds me of regolith. Makes me sneeze to think about it. And what caused regolith was years and years and years of actually just being struck. So it pulverized the surface of the moon. Footprint. So we talked about tsunamis a minute ago. Tsunamis are because, was it Mexico had a bad earthquake recently? The reason we have active volcanoes and earthquakes has to do with the fact that our interior of the earth actually has a liquid mantle part. And rock, that's liquid rock. And the only way it can be liquid has to do with it's got enough heat retained from the Earth's formation. Well, the moon cooled down faster than the Earth. So the moon is not currently geologically active. Okay. And when I say that, it's like, well, might it be geologically active later? No. Okay, it's cooled down. It was ooey gooey, and it did have some liquid to it in its early times. Okay. And the liquid actually came in part from the radioactive decay that happened in the interior of the moon. So if it had some ooey gooiness, this is actually what it allowed to happen. So all this is saying is that actually as the heat built up from radioactive decay within the moon, after the crust was kind of formed, enough heat built up and there were some kind of weak spots in its crust to go ahead and melt its crust and to have that liquid come up and then freeze in place. And that's what gives us our cool looking, our mare. That's what caused our mare. Pogo stick? Okay. So anyway. This is a mare, and the mare are named actually. And like I think I might have said, that's my idea is I want to be able to look at a crater, say the crater's name, look at a mare, say the mare's name. Well, I told you Tycho crater, you kind of know what that is now. But this is the Oriental mare. So let's pick up here on this slide because I want to go to these links and kind of show you how you can kind of get up and close with them. So we'll see you maybe on Tuesday, okay? If not, on Wednesday.